Welcome to the Explainer. Today, we're going to be listening in on something that sounds, well, impossible. The sound of a brand new black hole. And it's not just one. We're talking about a whole cosmic symphony here. Yeah, I know. This headline, it's fresh off the press from just yesterday, and it sounds like something straight out of a sci-fi movie, right? Crying black holes. But believe it or not, this is describing a very real and frankly groundbreaking discovery. Scientists have actually detected what they're calling the cries from the birth of two new black holes. Okay, but wait a second. How can you possibly hear a black hole? I mean, that's the big question, isn't it? We all know the saying, in space, no one can hear you scream. So to get to the bottom of this, we've got to figure out what scientists are actually listening for.
Right, so they're not sound waves like the ones our ears pick up. They're what we call gravitational waves. Think of it like this. Picture space-time as a giant stretched-out trampoline. Now imagine two massive bowling balls, our black holes, spiraling into each other and crashing. That collision sends ripples out across the trampoline, right? Well, that's exactly what a black hole merger does to the fabric of space-time. And those ripples are the sound that scientists are tuning into.
So how do we hear them? Well, we've got these incredible cosmic ears on Earth. It's a whole global network of detectors. You might have heard of them: LIGO, Virgo, and Kagra. And these things are just unbelievably sensitive. In late 2024, they picked up something special. Two of the most peculiar, most revealing signals they have ever recorded. All right, so let's dive into the evidence. What did our cosmic detectives actually find? Because these weren't your run-of-the-mill black hole collisions. No, these were strange, really strange. So get this, they detected two signals, less than a month apart, both from galaxies incredibly far away. And at first glance, you might think, okay, two pairs of black holes merging, we've seen that before. But when you look at the details, those puzzling clues, that's where the story gets really wild. They were hiding some deeply strange secrets. Okay, so let's check out the first case file. This is GWG241011, and the crazy thing here is the speed. The bigger black hole in this pair wasn't just spinning, it was absolutely screaming. We're talking a blistering pace, something really close to the theoretical maximum speed allowed by physics. It's easily one of the fastest spinning black holes we have ever seen. And then there's the second case, GW24111110. This is a total showstopper. For the first time ever, scientists saw a black hole spinning in the opposite direction to its orbit. I mean, think about that. Everything in a binary system is supposed to kind of go with the flow, right? All spinning and orbiting in the same general direction. This is like finding a planet that decides to orbit its star backwards. It just shouldn't happen. It completely shatters expectations. So let's recap. We've got a record-breaking spin on one and a completely backwards pirouette on the other. What could possibly cause such bizarre behavior? Well, these aren't just random quirks. They're clues. And they're pointing to a very specific and very violent origin story. The answer isn't in how these black holes lived. It's in how they were born. So let's get into the leading theory here, because it's basically rewriting the book on how black holes evolve. We're not just looking at single, isolated events anymore. We're actually starting to piece together entire black hole family trees. The whole idea is called a hierarchical merger, and it's pretty much what it sounds like. Black holes can have, well, parents. See, in really crowded parts of the universe, like a dense star cluster, two black holes can find each other, merge, and form a new, bigger one. And that child black hole can then go on to merge with another one. It's like a cosmic family reunion. And this is the brilliant part. This whole process perfectly explains those weird things we saw. That incredibly violent first merger, the chaotic energy from it can give the new second-generation black hole a massive kick, spinning it up to insane speeds. Or it could literally flip its orientation entirely, which would explain that bizarre backwards rotation. It's basically inheriting the chaos of its own birth. So, and this is the really crucial point. This isn't just some neat idea on a whiteboard anymore. As Stephen Fairhurst, the spokesperson for LIGO, puts it, these events are tantalizing evidence. This is the first real, direct proof we've ever had that this multi-generational process of black hole creation is actually happening out there. But, okay, finding out how black holes are born is just one part of this amazing story. These discoveries are also a huge deal because they let us probe the very fundamental laws of our universe. Think about it. These mergers are basically the most extreme laboratories you could ever imagine. They create conditions so intense, so off the charts, that they become the ultimate testing ground for our understanding of gravity itself. I mean, it's pretty wild. Over a century ago, Albert Einstein, with his theory of general relativity, predicted that both black holes and these gravitational waves should exist. So every single time we detect one of these events, we get to ask the big question, was he right? 100 years later, does the theory still hold up under these insane conditions? So how exactly do we put the theory to the test? Well, a spinning black hole doesn't just sit there quietly. Its insane rotation literally twists and drags the fabric of space-time around with it. This leaves a unique signature in the gravitational waves, a specific higher frequency hum. You can think of it like a harmonic overtone on a guitar string. It's an extra layer of detail in the sound. And the result? Well, the signal from that super fast spinning black hole, GW241011, was a perfect match. I mean, a perfect match for what Einstein's theory predicted we should see. This was actually the third time we've detected this specific hum, and every time it just adds more and more proof. So far, 100 years on, Einstein is passing these cosmic tests with flying colors. Okay, so confirming Einstein is awesome, for sure, but this isn't just about looking backwards at old theories. These extreme black holes are also incredibly powerful tools for looking forward, for discovering entirely new physics. And this is where things get really mind-bending. This is where the largest, most massive objects in the entire universe connect to the smallest, most mysterious particles we can imagine. A rapidly spinning black hole can actually act as a giant cosmic particle detector. It's a pretty wild idea, but stick with me. Some theories predict that there might be these exotic hypothetical particles out there called ultralight bosons. Now, if these particles actually exist, they should be drawn to spinning black holes, and over time form a massive cloud around them. And this cloud would act like a brake, slowly but surely stealing the black hole's rotational energy and slowing it down. Okay, but remember our case file? The black hole in GW24111 is spinning incredibly fast. It clearly hasn't been slowed down at all. So just like in a good detective story, the absence of evidence, that missing slowdown, is actually powerful evidence itself. It tells scientists that if these ultralight bosons do exist, they can't have certain masses. We're actually ruling out possibilities, which is a huge step. And that really brings us back to what Francesco Panarelli said. Each one of these new signals we hear from space teaches us something new. It sharpens our view of the universe, all the way from how stars live and die to the fundamental physics that governs reality itself. So these cosmic cries have already told us a brand new story about black hole families. But this is just the beginning. I mean, we've only just started to really listen to the symphony of space-time. What other secrets are still out there, just waiting to be heard? Thanks for joining us for this explainer.
If you're ready to explore the hidden truths behind mysterious sciences, subscribe now and become part of the enlightened society.